All the known atoms in the universe are organized in the periodic table, and the periodic table is organized by rows and columns. There are 7 rows in the periodic table. The bottom 2 rows actually part of rows 6 and 7. So there are total 7 rows, and they represent the energy levels of the electrons. So if you look at slide 15, it says it is easy to figure out how many energy levels an atom has by looking at the periodic table. The horizontal row, or the period, of the element corresponds to the number of energy levels, and this can be 1 through 7. So the question is asking, so how many, what's the period of the argon? So if you look at the periodic table, argon is right there, and it's in period 3. And that represents that the argon atom has 3 layers of electrons. Let's go to slide number 16, and it says something about the neutrons. So neutrons are also found in the nucleus of the atom. They're about the same size as the protons, but they do not have charge. They are neutral. So when we want to calculate the number of neutrons, we can take away the atomic number from the mass number. So there are questions again about the argon. And in slide number 17, there's more information about the electrons. So let's read it together. Finally, you have electrons. The electrons reside in the energy levels outside of the nucleus, and they have a negative charge. The electrons are much smaller than the protons or neutrons. This is why they are not included in the atomic mass. So the number of electrons do not really add the mass to the atoms. And let's read on. The number of electrons for a neutral atom will always match the number of protons. The electrons fill up the inner energy levels first before they move to the outer energy levels. The smallest energy level, the one that is closest to the nucleus, can only hold 2 electrons. The energy level the second energy level can hold up to 8 electrons, and the third energy level can hold up to 8 electrons. So if you look at the argon, argon has the atomic number of 18, and which means that it has 18 protons and 18 neutrons. So if you want to place the electrons for argon, you have to first fill up the first energy level. So here's the first electron, second electron, and when there are 2 electrons, it's already full. So there's no more room in the first layer. And the next electron has to go to the second energy layer, and the second layer can fit up to 8. So I'm going to draw 8 more electrons. Okay, so here there are 2 electrons in the first circle and 8 electrons in the second circle. So we have total 10 electrons. But according to the periodic table, argon has 18 electrons, so you have to place 8 more electrons in the third energy layer. So you're going to have to draw 8 more. Okay, so total we have 18 electrons. So 2 in the first one, 8 in the second one, and 8 in the third one. So when you actually answer the questions, you're going to basically drag and drop those electrons and place it in the right circle. Okay, so you're going to have to copy more of these electrons because I didn't give you all 18 of them. Okay, so make sure you copy and paste more. Now, if you go to the slide 18, okay, it also talks about the group number. So excluding the middle portion of the periodic table, we can count the columns, column 1, column 2, and jump all the way over there, column 3, 4, 5, 6, 7, and 8. Now, these column numbers represent the number of valence electrons, and the term valence electrons mean the electrons in the outermost energy level. So let's take a look at the argon as an example. When I drew the electrons for the argon, I drew 8 in the outermost circle, and argon is actually in group 8. Okay, so the number of groups placed in the periodic table matches the number of the valence electron or the electrons in the outermost layer.